If you think about most people who argue against intellectual property, what they'll say is, oh, people create innovations just to, because they're interested in the thing, or, open source software, people are so self-motivated and so forth. So if you think the elasticity of innovation supply with respect to material rewards is low, you're going to want to give a low reward for innovation. And the reason is because it's not worth tolerating the dead weight loss that causes unless you get a lot of response in terms of how many innovations are created. Similarly, people who want to talk up innovations will say, oh, there's all this spillover benefits to all these other people created. You've got to reward these people more. So that's saying that this term is bigger, right? And on the other hand, the more costs you think are associated with monopoly compared to the profits that you give people, the more waste there are in these lawsuits and so forth, the greater this term is and the less intellectual property you want to give. Okay. So to try to look into this a little bit more in detail, I want to think about some demand form that allows us to vary how much dead weight loss you get for every unit of monopoly, right? Remember that the pass-through rate that we talked about before under monopoly affects both the ratio of consumer surplus to profits and the ratio of dead weight loss to profits. And the higher the pass-through rate is, the greater is this ratio of dead weight loss to profits, but also the greater is this consumer surplus over profits. A simple class of demand functions that allows us to modulate the pass-through rate is the constant pass-through demand functions. Now, you've actually seen some of these already in the course. One is the constant elasticity demand. Another one is the linear demand. Constant elasticity has constant pass-through of the elasticity over elasticity minus 1. Linear demand has constant pass-through of 1/2. Exponential demand, which we haven't used yet, but it's just negative exponential, has constant pass-through of 1. So the general form of demand functions that have constant pass-through is this, with the normalizations that we've been doing. 1 minus the pass-through rate times price, so the pass-through rate over pass-through rate minus 1. If you put in 1/2 here, you get linear demand. If you put in the elasticity over elasticity minus 1, and you cancel things out, you get the constant elasticity form. OK. So this form is very easy to work with because the consumer surplus basically looks almost exactly the same. And the dead weight loss has a simple expression, et cetera. So with this, we can do all the things that we were looking at on that previous slide. We just need parameter values. So there's been a number of studies that have tried to look at the elasticity of innovation supply. And they got a value of somewhere between about 0.5 and 1. And the way that they did this is they try to look at cases where there's a market and the size of demand in the market increases so that the profits that you'll make from creating any new product increase. And they look at how that affects the rate of innovation. So one example of this that was done by a student whose BA thesis I advised at Harvard a couple of years ago looked at the effect of the iPhone being made available on Verizon. I don't know if you guys remember that the iPhone used to only be on AT&T. Then they made it available on Verizon, and you got a lot more apps being created for the iPhone. And he used that to measure the effect of, the profits that you would make on market on innovation. Now, pass-through data is much harder to get. The Einov et al. Paper that we talked about showed that pass-through actually might be infinite in some places. But there was a paper by David Pasenko and co-authors who showed that usually pass-through is somewhere between 0.5 and 2 in a monopoly situation. And I'm going to run with that assumption, imagining that pass-through is between 0.5 and 2. And then we have this constant pass-through form. So I did this little simulation of just intersecting the curves corresponding to the two sides of that equation that I showed you before. If we increase the pass-through rate, that raises both the consumer surplus to producer surplus ratio, and therefore this line curve moves up. But it also increases the dead weight loss to profits ratio. Turns out that that second effect dominates, and the optimal level of intellectual property is lower when the pass-through rate is 2 than when it's 1/2. On the other hand, when the elasticity of innovation supply rises, that just moves this one curve and therefore increases the optimal level of intellectual property protection. OK. And what you basically get is that over the parameter range we've been talking about, the optimal intellectual property protection ranges between about 0.45 and 0.65 of the monopoly optimal price. OK. So Matt Klein, what sorts of things might we look for in the real world to try to figure out whether intellectual property protection in practice is around 0.45 to 0.65? Like, what number could you line up with that?
Can you ask the question in a different way?
Yeah, so like 0.45 intellectual property protection, what the hell does that mean?
Right.
I mean, it's like, OK, 0.45. Like, what things in the real world in terms of like patent policy could we look at that we could like quantify how much intellectual property protection they're giving?
OK.
Have any thoughts?
Sure. I don't know. I guess you look at patents on novel series, or on book series, and talk about or look at how profits after the first book change.
Yeah, that's an idea. Ned, did you have an idea, or?
I guess you could look at. I would look at how many times the patent is actually being licensed. Versus how many times. Versus how many times people who want to license
Can't get it. Yeah, that's an interesting idea. Anyone else have any other ideas? Something that might be like pretty easy to do? Yeah, Jacob.
I mean, we said the two things we cared about before were strength of the patent and
Yeah.
so we could analyze length sometime.
Yeah, length is something that's very easy to analyze quantitatively, right? Because we like know how many years of the patent life you do it. And here's like a simple calculation we could do. In the US, you get 20 years of patent life. Let's assume that there's a 5% interest rate. Well, then a natural thing you can do is you can compute the fraction of having the patent forever that having it for 20 years constitutes, right? Because having it for 20 years, you know, in a discounted sense, is going to be some part of having it forever, and we can calculate what that is. So in fact, the way that you do that, if you assume that the patent is equally valuable in every year, which is also probably not a great assumption, but it's some sort of an approximation, is 1 minus 0.95 to the 20th power, which gives you that having it for 20 years is 64% of having it forever, right? Which is pretty close to the range we were looking at, right? Now, of course, you know, an optimal calculation should actually take into account other harms and benefits rather than just the static distortion we were talking about and so forth, right? It should talk about the depression of follow-on innovations. It should also think about the benefits of patent protection in terms of getting firms to disclose. But another thing to notice is that patent protection should almost certainly differ from industry to industry. Just like we did in third-degree price discrimination, when there were like observable characteristics that made some people more elastic and others more inelastic, we varied the pricing we had to them. And similarly, if there are some industries where there's a lot of deadweight loss for every unit of profit, or there's a low elasticity of innovation supply, we'd want to have weak intellectual property protection there. And we'd want to have stronger in industries where there's a large elasticity of innovation supply and there's not so much deadweight loss. So for example, I think that there should probably be a lot weaker patents in the tech sector and probably a lot stronger patents in the pharmaceutical sector. Why? Because in the tech sector, a lot of people develop stuff relatively cheaply, and they're, to a large extent, sort of like partly self-motivated or sort of like tech nerds or whatever. And I don't think it's as much motivated by material considerations. Also, determining what is or is not covered by a patent is really, really hard in the tech sector, and therefore it makes there be a lot of really costly patent litigation. On the other hand, in pharmaceuticals, it's usually pretty clean what you have patented, right? It's like some particular medicine. And on the other hand, and price discrimination makes it possible to capture a lot of the benefits so that it's not so costly, the distortion is not so costly. On the other hand, it's very expensive to develop pharmaceuticals, right? Especially because of the FDA process and so forth. And therefore, that makes innovation very elastic to rewards, right? And that makes optimal intellectual property much higher. So I think that unlike the US law currently, there should probably be differences in IP policy across industries. Okay, so while this is sort of like the most basic trade-off with intellectual property, many other tools are used to encourage innovation in practice. So research and development subsidies are direct government grants or tax deductions for developing new products. The National Science Foundation funds research of people like me in order to develop new products. Also, many private labs, like at Microsoft or Yahoo, to get good public publicity, often fund research. Another tool that you could use to encourage innovation is prizes for new innovations, or the government coming in and buying out patents. So they can eliminate the deadweight loss if the government comes and buys the patent and then makes it freely available to use. And this was very popular historically. Many governments during the 19th centuries offered prizes for innovations or bought out existing patents. And it's starting to get popular again with the introduction of the X prizes for various different breakthroughs. But those are privately funded, that's true. Yeah. So the government can also give subsidies for purchasing innovative products, which will encourage firms to produce them as they'll know they'll make more profits. So one argument for subsidizing the use of green energy was that that would encourage people to develop new green energy products. Another trade-off is about how strong do you make patents versus how long do you make them last. Those are two different dimensions, as Jacob mentioned, and there might be some trade-off between doing those. Another thing is how stringent requirements do you put on in order to actually get patent protection. So the Patent Office looks through patent applications and tries to figure out whether they're novel, like different from other things that came before, whether they're useful, and whether they're not obvious. And they try to screen innovations, patents, whether things get patents based on that. And there's a big question of how we should interpret those economically or even in the law, which are interesting. Another issue is if, often innovations build on top of each other. And there's a question of how the courts should view the claims of various people when they're fighting over who should get how many profits from the eventual thing, given that the patents built on top of each other, right? And often it makes sense to have those patents actually pooled together into one pool so people don't have to separately license all the constituent patents, right? And for each of these different tools, there are different trade-offs. So, research and development subsidies encourage more innovation. Corporate taxation discourages innovation because people are going to eventually form a corporation to sell those products, and if they're making less profits afterwards, they're less likely to develop things. The benefit of giving research and development subsidies is that even beyond the profits that companies end up making, they create this extra consumer surplus. If you want to subsidize them for that consumer surplus, that's a benefit of giving R&D subsidies or lowering corporate taxes. But on the other hand, you might want to redistribute from entrepreneurs to people who are less well off. And that's what the corporate tax sort of tries to do. So that's a trade-off we'll talk about during the next lecture. My job market paper, when I was, what got me the job here at Chicago, explored the trade-off between intellectual property and prizes. So there's a very nice quote from Adam Smith where he says that the problem with giving out a